Hello and welcome back to my YouTube channel. We were discussing bitwise operator, and in the previous tutorial we discussed bitwise AND operator. Next, let's talk about bitwise OR operator. Symbol used to represent this operator is this. Syntax is left operand, bitwise OR operator, right operand. This is a binary operator. Bitwise AND is also a binary operator. And here operand can be value, variable or expression, but final result will get from that expression, or if you use variable here, it must refer the integer number. As we know, bitwise operator works only on integer number, right? So operand must be integer number. This operator compares the binary representation of two numbers bit by bit and returns new number, where each bit is 1 if the corresponding bit of either input number are 1. Here you can refer this table. If both the bits are 0, then only output is 0, otherwise output is 1. Okay, so let's understand how bitwise OR operator works. Let's take an example here, 2 or 5. So binary representation of 2 is this, binary representation of 5 is this, and perform bitwise OR operation. So if both the bits are 0, then only output is 0, otherwise 1. So here we got the final output, and bitwise OR operator returns the output in the decimal format. So this is the binary representation of decimal value 7. 2 or 5, it is 7. 3 or 5, it is 7. 9 or 1, 9. 3 or 5. Okay, if I want -3. So this is about bitwise OR operator. Okay, next let's talk about bitwise XOR operator. Symbol used to represent bitwise XOR operator is this. Syntax is left operand, bitwise XOR operator, right operand. It is a binary operator. Bitwise AND, bitwise OR, bitwise XOR. These are all binary operators. So operands can be variable or expression, which refers to or evaluate to integer number. This operator compares the binary representation of two numbers bit by bit and returns a new number, where each bit is 1 only if the corresponding bits in the operands are different. Otherwise it is 0. So here you can refer this table. If both the bits are 0 or 1, if it is same, then output is 0. If it is different, that is one is 0, another one is 1, then output is 1. Here returned result is a decimal number. Just for an example here, 2 XOR 5, binary representation of 2 and 5 is here. If both the bits are same, write 0, otherwise 1. Here we got the final output. So if you want to convert it to decimal number, then here you can see the output. Okay, here we can see few examples. Alright, so this is about bitwise XOR operator. And the next bitwise operator is NOT operator, bitwise NOT operator. Symbol used to represent bitwise NOT operator is this. This operator performs bitwise inversion on the binary representation of integer number. It is a unary operator. So syntax is this. The bitwise NOT operator flips each bit of operand, changing zeros to 1 and ones to 0. The result is new number, where every bit is the complement of the corresponding bit in the original operand. You can refer this table. Operand must be an integer number, so it can be an integer number or a variable which refers an integer number, or an expression which results in integer number. Final result is in decimal number format. For example, here I have 5. If I use bitwise NOT operator on 5 like this, so it will flip every bit of binary representation of 5. Here we can see the binary representation of 5. Flip every bit. So this is actually binary representation of -6. If I take a negative number like this, -6, flip every bit, then we'll get the result as 5. So here 5, output is -6, actually 4. Okay, and if we take the number, integer number as k, when I use bitwise not operator on k like this, so output is k plus 1, negative k plus 1. If k is a negative number like this, then it is positive k minus 1. Okay, so this is about bitwise not operator. Bitwise not operator is a unary operator. Okay, so that's it for now, guys. Thank you for watching. Don't forget to subscribe to my channel. I will meet you in next class. Till then, take care.